In an n-type silicon, which of the following statement is true? So option A, electrons are majority carriers and trivalent atoms are the dopants. Electrons are minority carriers and pentavalent atoms are the dopants. Option C, holes are minority carriers and pentavalent atoms are dopants. Holes are majority carriers and trivalent atoms are the dopants. Now, so first of all, should know to answer this how an n-type semiconductor or n-type semiconductor is formed. So in order to form n-type semiconductor, basic semiconductor like silicon or germanium should be doped with purity that impurity which is having a valency of 5, which is greater than 4 for silicon or germanium, such that the electrons are more than required for the bond formation. So what is the bond formation you have to understand? So generally if you consider silicon, so it has 4 electrons as valency. So it can make a covalent band to 4 other silicon atoms. Okay, so this is one bond. So this silicon also 4 electrons. Silicon also 4 electrons. Silicon also 4 electrons. Silicon also 4 electrons. Now it can form bonds with the 4 other silicon. Now if you are doping with a pentavalent atom, so for bond formation, how many electrons are there? 4 electrons are there in the bond formation. Once you dope with a pentavalent atom, so pentavalent atom like phosphorus, so it will replace one of the silicon. Let us say this is the silicon. So in the place of we have phosphorus, it has 5 electrons. Now what is the required for the bond formation? 4 electrons are sufficient for the bond formation. For bond formation. So once the 4 electrons are sufficient, the remaining electron is free. So there are free electrons. and electron and hole pair also exist at room temperature, but pure semiconductor in pure semiconductor the n concentration is equal to p. But when you are doping with p type, sorry, when you are doping with the pentavalent atom, so automatically, so the number of electrons will be more than number of electrons there is free electrons more than free. Okay, so the answer from the above, so what is the answer from the above? So the option is in n-type silicon, which of the following statement is true? Electrons are majority carriers, so this part is true. So here also this part is true. So you have to dope with pentavalent atoms as the dopants. So you have to, so pentavalents are the dopants. So this is not applicable. So anyway, holes are not majority carriers. Holes are, sorry, holes are, this part is correct. Holes are minority carriers. Holes are minority carriers. Okay. Pentavalent atoms are the dopants. So this is also correct. So A is correct. Holes are minority carriers. Pentavalent atoms are the dopants. So these two are correct. And holes are majority carriers. This is wrong. Actually, electrons are the majority carriers. The trivalent atoms are the dopants. So this is not correct. So pentavalent atoms are there. So the answer for this is both B and C.